worst nightmares combined.
So we're going to start the lesson on perfect square trinomials with multiplying. If you have a binomial with a squared out here, what that really means is take it times itself, and then you would have to multiply using our FOIL method. So x times x is x squared. X times 5 is 5x. 5 times x is 5x. And 5 times 5 is 25. Now, because it's the same number twice, these numbers in here are the same. And when we add them together, it just doubles what that was, except I didn't do it. So 5x and 5x make 10x, not 5x. 10x plus 25. Okay? We're going to do a couple of these, and we're going to look for some patterns. So this one's pretty easy. The 25 is 5 squared, or 5 times 5. And then the 10x is 2 times 5, or you could think of it as 5 plus 5, either way. So that's the pattern that we see with this first one. The second one, if we write it out to multiply, it'll look like this. We'll have 2x times 2x, which is 4x squared. 2x times 4 is 8x. 4 times 2x is 8x. And 4 times 4 is 16. And then we put these together. We get 16x in the middle, 16 on the end. And so that's what we get there. So on this one, this is 4 squared. The 4 is actually 2 squared. And then the 16 in the middle is 2 times 2 times 4. So you had the 2 in the problem, you had a 4 in the problem, and then you doubled that. So there are patterns. And I will show you what the pattern is, and I will explain that people believe there's a shortcut, but then I'm going to relate this to just stuff we've done before, because sometimes I think this shortcut is more like the long route. It's like the shortcut my dad used to make in the car, and we'd get lost. So, all right, so perfect square trinomials. If you have a plus b in parentheses squared, you get a squared plus 2ab plus b squared. So there is a pattern there, and this is a nice shortcut if you have to multiply something that's being squared and you don't feel like doing FOIL. Going forwards, I think, is kind of a shortcut, but going backwards to factor might not actually make that much sense to you guys. But we'll talk about it. Okay, so we get down here on number 1. It's going to look a little familiar because I messed up. If we're just thinking about this as something to factor, this has the x squared plus bx plus c format that we solved using the x puzzles. Multiplies to make 25, adds to make 10. And so we would just get 5 and 5. I'd have x plus 5 and x plus 5, which we can write as x plus 5 squared. That's a little shorter. And the idea is I could look at this and go, oh, that's 5 squared, and that's 5 times 2. It's just going to be x plus 5 squared. In theory. Yeah, the shortcut, I haven't had a lot of students that liked using that formula to go backwards. So I think what I'm going to do with you guys is just go through and factor them like we've been doing. And then on the answer, we'll write squared on the end, and it'll be fine. So on the next one, it's got the same kind of format. We're looking for numbers that multiply to make 64 that add up to 16.
8.
So 8 and 8. So we'd have x plus 8 and x plus 8. And you can, if you want to, you can just go straight to x plus 8 squared. By the way, these, oh, I guess we already talked about, these are called perfect square trinomials because they're trinomials. They have 3 terms, but we can factor them into a perfect something squared. I didn't really explain that before, so hopefully that'll help. Let's take a look at 3. 3 looks a lot like the others, has the same format, so we're going to multiply to get 100 and add to get 20. So that'll just be 10 and 10. So you'll have x plus 10 squared. I'm just going to skip to that point. So where it gets interesting is where they start putting a coefficient in front of the x squared, something that's not just x squared. So the first thing you want to look for is if you can take out a greatest common factor. So I've got 4 24 and 36. Will 4 come out of all of those? Yes, so let's do that. So we're going to take a 4 out. So I would have x squared in the parentheses. What do I take times 4 to get 24? 6. So I'd have 6x. And then what do I take times 4 to get 36? 9. And then this part that's in the parentheses has the pattern that we can do this. So it multiplies to make 9. Adds to make 6. So 3 and 3. So these are the ones that you keep the 4 in front, and then we can just write x plus 3 squared. And that would be the answer.
That's pretty fun.
Okay, good. All right, so when we get to number 5, I notice I cannot take a 9 out of everything. I can't actually get anything out of 25 that goes into 9 and 30. So that means I am stuck doing the slide, divide, bottoms up method. So I'm going to take this times 9, so I'll get x squared plus 30x plus 225. You might recognize 225 as a perfect square. If you take 15 times 15, you get 225, and lucky for us, if we add 15 and 15, we get 30. So that part in there is going to be x plus 15, x plus 15. I'm going to go ahead and leave these separate because I multiplied by 9 up here, which means I need to divide both of these numbers by 9 down here. And I have to reduce the fractions. So what number goes into 15 and 9? 3. So if I divide those by 3, I get 5/3 on both of them.
You're going off the screen there.
I thought we could do fractions.
So then when you have a fraction and it doesn't completely reduce, then you bottoms up. So you do the fractions, but you don't leave them as fractions. So then you bottoms up. So you reduce the fraction that's there as much as possible, and then the denominator comes up in front of the x. And you could write it as 3x plus 5 squared in your final answer, which I will get on the screen. There we go. Okay? So this is that little tidbit that I told you guys is interesting with that method, is you have to reduce the fractions. Because imagine that I hadn't, and I just took the 9s up, then I'd have 9 times 9, which would give me 81 here, not 9. So I need the 3 and the 3 to make the 9 if I was going to multiply it back out. Okay, so let's go over to number 6. I have x's and y's, but don't let that freak you out.
What's the y too?
And there is, oh, that's supposed to be squared. It just didn't get,
Oh my God.
so that's a power. Just make it little. It'll be fine. So what we want to do is use the same method we did before and sort of pretend that it's just 4x squared minus 12x plus 9 for a second. The y's we can add in a minute. So pretend it's just that. We take the 4 down here and multiply it. And so I'd have x squared minus 12x plus 36. Except that really, I have xy and 36y squared. But the y's are just going to kind of ride along. It'll be okay. So we're trying to multiply to get 36 and add to make negative 12. So that's going to be negative 6 and negative 6. So I'm going to have x minus 6y. That's how we get the y squared. And x minus 6y. And then because we multiplied by the 4 in the beginning, I've got to divide those 6's by 4 and then reduce them. So 6 and 4 both reduce by 2. So I can make that 3/2 y. And then you go ahead and bottoms up the fractions. And 2x plus 3y. So you kind of get this weird y thrown in there. Sometimes they have that. And but you're still using the same method we did on the last one. You just have to add some y's in. And 2x plus 3y squared. And remember, you can always multiply these out using the FOIL method to see if you actually did this correctly.